All right, so what the heck is a polynomial? Well, the answer is buried in the meaning of the word polynomial. Poly meaning many, nomial meaning number. I find it more useful, rather than using the exact translation, to think of it in terms of many parts. So a polynomial is actually one single number with many parts. Let's look at one of the parts first. Each part of a polynomial, the parts are called terms. So many terms would be a polynomial. Let's look at just one term. One term contains three parts of its own. It has a sign. It has a numeral. And it has a variable configuration. So let's look at the sign first. Well, that's obviously the easiest thing. There are only two choices. They're either positive or they're negative. Next is the numeral. Now, numerals are the things we're used to thinking about when we talk about numbers. 1 would be a numeral. -8, a numeral. 1.7, totally a numeral. 3/5, also. So it's the thing that we typically think of as a number before we get to polynomials and understanding what a polynomial is. And then variable configuration means some arrangement of variables. So for example, we're used to the variable configuration x or y, but it could be a combination. It could be x squared y or a cubed b squared c or d j h to the 5th power, some configuration of variables. Now let's talk a second about what's not a part of a polynomial. In this case, the only limits are on the variable configurations, or excuse me, on how the variable is used. So for example, when it comes to the numeral portion, we can't have a variable in the denominator or in the power. So -8 to the x. So we can't have a variable configuration or variable attached to the numeral by being either in the denominator or raised into the power. And another way of writing this one, of course, is that the variable cannot be x to the -1, which would be like this. So no negative powers. So what we're looking for when we eliminate values or parts of a polynomial or parts of a term is the variable cannot be in the denominator, cannot be in the power, and cannot have a negative power of its own, which of course puts it into the denominator. Okay, let's put together our first term then. So how about negative for a sign? I'll use a simple numeral. I'm going to use the number 2. And let's use a relatively simple variable configuration. So -2xy squared. So we've actually worked with numbers that look like this before. We didn't necessarily define them as specifically as we're doing today, but we've worked with them, so it's not so foreign and new to us. Remember, this is called a term. That's the official name for a part of a polynomial, one part of a polynomial in particular. Now let's give names to the other parts. Well, the sign is called the sign. The numeral part has its own name in a term, and it's called a coefficient. And then the variable configuration is just the name of the term. This is how we name a term. So this term would be the xy squared term. That's the name of the term. And then we care about the powers for their numeric value. So even though we don't write a 1 on the x that's to the first power, it does have a numeric value of 1. And if you take those all together, they're the degree. So this is a third degree because 2, 3, add the powers up, third degree polynomial with the name of xy squared term, a coefficient of 2, and a sign of negative. So we would say the coefficient of -2. So these two can be actually taken together. All right, so let's do a couple of examples. First, determine whether this is a polynomial. -4 x squared y, and then name the parts. So there's a sign, there's a numeral, and there's some variable configuration. Definitely a polynomial. So what are all the ways we could describe this? We could say it's a third degree, right? 2, 3. So it's a 3 degree. It has coefficient -4. And its name is x squared y term. Well, that was easy enough. Let's do it again. So 2.8 x cubed AB. First, determine if it's a polynomial, and it is, because I have a sign. It's a plus sign. Just because I didn't write it doesn't mean it's not a positive. 2.8 is a numeral, and I have x cubed AB, a variable configuration. Now let's break it down. So this is a 3, 4, 5, so it's a 5th degree. Coefficient 2.8. Going to abbreviate the word coefficient because it's long and I don't want to write it over and over. Coefficient 2.8, and you're welcome to do the same thing, by the way. And it's an x cubed AB term. Okay, let's do another one. 8. Is 8 a coefficient? Is 8 a term? Well, there's a sign. It's a positive 8. There's a numeral. The numeral is 8. And there is a degree, a variable configuration. There is, believe me. The variable configuration actually on this is that the x has a 0 power. Remember, anything to the 0 power equals 1. So this is really just 8 times 1, which equals 8. We don't write the 1 down when something is times 1. And we don't write the variable down when it's x to the, or some variable to the 0 power. All of this is not written, but this is still a polynomial. So let's go ahead and break it down then. So it's a 0 degree. Coefficient is 8. And the name of this term, we don't call terms like this. We don't use the name x to the 0 term. We actually call this special case the constant term. In fact, we don't even really tend to call the 8 a coefficient at all. So when you have just a numeral, seemingly nothing else there, you really have the sign, the numeral, and the variable configuration, but we call it all together a constant term. If that was all I had and I had to break it down, I would call it a 0 degree, but that almost never comes up because these are just numbers like we've been working with forever. So really, you've actually been working with polynomials and you didn't necessarily even know it. All right, so you might be asking yourself, well, if polynomial means many parts and a term is only one of the parts, how else can you put together many? No worries. Let's talk about that. So the 3 terms that I've shown you here, let's go ahead and write them back out. negative 4x squared y term, the 2.8x cubed ab term, and the 8 term, right? The constant term of 8. These are all called monomials. And they're called monomials because mon means one in the same language of polynomials, and nomial part, right? So one part. This is one part. This is one part. This is one part. So what would a binomial look like? Well, we know that bi means 2, and so let's put 2 of the parts together. Well, let's see. Let's take the 2.8 x cubed ab and the first term here, negative 4 x squared y. Look what happened. That negative sort of became an operation, didn't it? And I have now one number. This whole thing is one number, and it has 2 parts. That's the first part. That's the second part. Remember, the sign goes with the number. So, or excuse me, with the term. So this is all one number called a binomial. It has 2 parts. What about a trinomial? Trinomial, implying 3, would do exactly what you think. 3 parts. Let's see. Let's take the 2.8 x cubed ab minus 4x squared y, and then put the 8. Now, I need something to divide these, right? I didn't put the plus sign up here. It was there, but I didn't write it because it would be redundant when it's in the front. If I haven't put a negative, I assume it's a positive. But back here, I have to write the plus sign in front because I have to separate this term somehow from this term. So we're looking now at a trinomial, which is 3 parts, one number, 3 parts. So a monomial has one part, one part, one part. A binomial has 1, 2 parts, and a trinomial has 1, 2, 3 parts. After that, we tend to just call them 4-term polynomial, 5-term polynomial, rather than having a special name for them. So the last bit of information that you need to know at this stage about polynomials is that they are generally written in something called descending order. Descending order meaning, let's see, where am I going to put that? Descending order. That just means the highest degree first, the next highest degree, and then the next highest degree term. So in this case, for the binomial, the first term is an x cubed, let's see, it's a 3, 4, 5, and the second term is a 2, 3. So the 5-degree term comes before the 3-degree term. This last one, well, I already know that this is 5-degree term, and then a 3-degree term, and then a 0-degree term. So these are all written in descending order. Also, when it comes to naming, sort of doing this breakdown, the degree of a polynomial is only considered by the first term. Once you've written them in descending order, and let's write descending order by degree, right? So descending order by degree of the term. Then you can name them the polynomial based on the degree. So we've already broken down the monomial based on the degree up here. So the binomial here, this would be called a 3, 4, 5, 5-degree binomial. So if I asked you to classify this number, you would say it's a 5-degree binomial because there are 2 parts written in, and the highest degree on one of the parts is 5. Down here, this would also be a 5-degree trinomial. So the degree comes from the highest degree monomial, the one that's written in the front when you write it in descending order. So for example, if I had written negative 4x squared y first, plus 2.8 x cubed ab, this would still be a 5-degree binomial. It just wouldn't be written in descending order. So if I asked you the degree of this polynomial, two-parted number, if I asked for the degree of this number, you would have to look for the biggest degree even if it wasn't written in the front. But technically, you should rewrite this so that the highest degree is in the front. So now you know what the heck a polynomial is. It's one number that has a bunch of parts in it. Doesn't matter how many parts. It could have 79 terms in it. That would just be a whatever degree 79 term polynomial.